Hi, we're going to keep going, and I'm going to do the last problem in the problem set, or excuse me, from the practice problems for chapter 9. So let's look at this problem. The mean number of sick days an employee takes per year is believed to be about 10. Members of a personnel department don't believe this figure. They randomly survey 8 employees. The number of sick days they took from the past year are as follows: 11, 5, 14, 3, 9, 10, 6, and 8. Let X be the number of sick days they took the past year. Should the personnel team believe the mean number is 10? Conduct a hypothesis test at the 5% level. All right, this is something that we haven't seen now. I've got to enter my own data where before all my stuff was given to me. But let's look at one important thing. You don't see anything here about a population standard deviation. Because it doesn't give you a population standard deviation, you need to go ahead and know this is a t-test. All right. First thing we need to do, let us go ahead and figure out those hypotheses. Okay. So it doesn't have anything about directions. It just says they believe the mean number is 10. So this will be my null hypothesis, that I believe the mean is 10. The alternative is I don't believe the mean is 10. Why? It gives no direction if it's higher or lower. It just says it is equal or not equal. All right, so let's look at my random value for X. All right, what were they trying to look at? They're looking at the average number of days that employees take each year. So let's go up here, right? They say they're looking at the average number of sick days an employee take a year. Okay, this is the only one that will satisfy that. The average number of sick days employees take each year. Okay, so we keep going. All right, you'll watch what I'm going to do, because if you do it wrong, it's going to get mad at you, and I don't want you to get it wrong. Okay, so let me go back up. How many data values do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go down here. I'm going to click in the box, and I'm going to hit function. And I'm going to have to put it in this format. So the first thing I have to do is T, and then I have to lower it. And this is going to make it, I've got to do degrees of freedom. For this, your degrees of freedom is your sample size minus 1. So for me, it's going to be T to the 7. Because if I look at that, I know it's a T distribution, and my degrees of freedom are 7. The degrees of freedom, T distributions are a lot like normal distributions, but because they have smaller sample sizes, your ends think of a normal distribution, think of the ends going to negative infinity and to infinity. They will be different based on your degrees of freedom. That's really the only difference that would tell you in the real world when you're doing statistics. Okay, you know it's a T. So let's go ahead right now, and I'm going to show you how to put it in your calculator. So turn it on. First thing I got to do is I got to go to stats, and I got to enter my data. So my first one was 11. My next one was 5. My next one was 14. Then it was 3. Then it was 9. Then it was 10. And then it was 6. And then it was 8. And yours will be different because all the numbers in red mean they're different numbers. All right, I'm going to go to stat. I'm going to go over to test, and this is a t-test. So I hit enter. You know how we've always been using stats? Now we're going to change it and hit data because I just entered data. So now I need to put what my mean was. That was in my hypothesis, which was 10. L1 is my list. Frequency is 1. You need to make sure it's that way and that you have your data in L1 or it will not do anything for you. So I'm going to hit enter here because I want it to be not equal. Why do I want it to be not equal? Because here's my alternative. Okay, from there, I go ahead. Oops, don't open that. Okay, go here. Then I hit calculate, and then I hit enter. Boom, look at all the stuff it gives me. Okay, so my T is negative 1.400. Okay, what else does it want me to do? So then it wants me to go down here and give my p-value. So let me go look at my p-value. So my p-value, go back to my calculator, is 0.2042. So I'm going to put that in there, 0.2042. Okay, so now what do I want that to be? So I need to see what's going to make, for the p-value, what it's going to mean for the null. So if the null is true, then there's a chance equal to the p-value that the average number of sick days for employees is at least as different from 10 as the mean of the standard deviation, as the sample is different from 10. Because all I'm saying there is this p-value says that my sample is no different from my population, or is at least different than the population. You can think of it this way, because all we're doing is we're comparing the sample to the population. So the false ones are never going to be good. It's only going to be the true ones, okay? So I got to look at it, and I want to say that it's at least as different. So that's the one I pick. And then I go here one more time. My alpha, what did we say alpha was? Alpha was point is 5%, so I convert that. I'm going to convert it to this. This is just a habit I have. All right, what is my decision? So is P 0.2042 less than alpha? No, it is not. So I do not reject my null. And the reason I don't reject my null, think of it this way, because my alpha is less than my p-value, I just don't reject it. All right, so if I don't reject my null, let's go back up to it. That means I've got to keep my null. So what does that mean? So that means there is not sufficient evidence used per year by an employee that is not equal to 10, okay? So there's not sufficient evidence to conclude that the average number of sick days used per year by an employee is not equal to 10 days, okay? So think of it that way, all right? You've got to think of these kind of things. And go back to your conclusions sheet, and remember there's cases for when there's an equality sign and when there's not an equality sign, okay? I hope this helped. If you have questions, you can reach out to me. And of course, use the sheets I gave you because they should help. Thanks.